Messier 44. The Beehive Cluster. Introduction. Messier 44, also known as the Beehive Cluster or Precipe, is one of the most fascinating open star clusters in the night sky. Located in the constellation Cancer, it has captivated human imagination for millennia, serving as a celestial landmark for ancient astronomers, a subject of myth and folklore, and a key target for modern astrophysical research. This fully expanded encyclopedia covers every conceivable aspect of M, including astronomical properties, historical records, mythology and cultural significance, scientific mysteries and theories, observation guide, best viewing times, equipment recommendations, astrophotography tips. 1. Astronomical characteristics. A deep dive, fundamental data and discovery, catalog designations. Messier 44. Listed by Charles Messier in 1769, NGC 2632. New General Catalogue Entry. Calendar 189. Per Calendar's 1931 Open Cluster Catalogue. Melot 88. From Philibert Jacques Melot's 1915 catalogue. Common names. Beehive cluster. Resembles a swarm of bees when viewed through binoculars. Precipe, Latin for manger, tied to ancient mythology. Constellation. Cancer, right ascension. 08 H40 meters 24s. Declination, plus 1940. Galactic coordinates. 205.5. Plus 32.5. Distance and size. Distance from Earth. Hipparchus, approximately 522 light. Gaia DR3, approximately 577 light. Apparent diameter, approximately 95 arc. Physical diameter, approximately 1215 light. Age and stellar population. Estimated age, 600 to 730 million years. Number of stars. Total members, approximately 1,000. Bright stars, approximately 350. Dominant spectral types. F-type approximately 20%. G-type, approximately 30%. K-type, approximately 40%. A few M, white dwarfs, and red giants. Brightest stars in M44, star name magnitude spectral type, Epsilon Cancri, plus 6.29 KO3 red giant. Brightest in cluster, HD 73710 plus 6.94, FOV yellow-white main sequence star. HD 73534 plus 8.24 G5 IV hosts. Exoplanet HD 73534 BU Concrete plus 7.44 KOE eclipsing binary system. Dynamics and velocity dispersion approximately 0.5 kilometers per second. Escaping stars. Approximately 30% of members will likely disperse within 500 million years. Tidal disruption. The Milky Way's gravity is slowly pulling M44 apart. 2. Historical observations. From antiquity to modern day. Prehistoric and ancient records. Stone Age. Likely visible to early humans as a fuzzy patch. Babylonian astronomy. Possibly recorded as a cloudy star. Greek and Roman era. Hipparchus called it a little cloud. Ptolemy listed in the Almagest as a nebulous mass. Aratus described it in Phenomena as a dim spot. Medieval and Renaissance observations. Persian astronomers. Al-Sufi noted it in the Book of Fixed Stars. Johann Bayer marked it in Uranometria but did not resolve stars. Galileo Galilei first to resolve approximately 40 stars with his telescope. Modern discoveries. Charles Messier added to his catalogue to prevent confusion with William Herschel studied its structure. calling it a beautiful cluster. 20th century, photometric studies revealed its true distance. Radial velocity measurements confirmed membership. 21st century, Gaia mission, precision, astrometry of member stars, exoplanet discovery. HD 73534b, a Jupiter-like planet. 3. Mythology and cultural significance. Greek and Roman legends, the manger and the two donkeys, Ocellus borealis and Ocellus australis, represent two donkeys feeding from the manger. Dionysus and Silenus myth, the gods disguised themselves as donkeys and were placed in the sky. Hercules connection. Some myths link it to the crab crushed by Hercules. Chinese astronomy. 23rd lunar mansion, part of the ghost constellation, exhalation of piled-up corpses, a poetic name reflecting its misty appearance. Native American lore. Cherokee saw it as children who climbed to the sky to escape a monster. Lakota Sioux interpreted it as smoke signals from star spirits. European folklore. Weather predictor. If invisible on a clear night, storms were coming. Little cloud in medieval Europe. Farmers used it to predict harvests. 4. Scientific mysteries and theories. 1. Shared origin with the Hyade. Similar age and motion. Both clusters may have formed in the same giant molecular cloud. Discrepancy. Hyades is closer, suggesting different birth regions. 2. The missing white dwarfs. Expected approximately 20 to 30 white dwarfs based on stellar evolution models. Observed only approximately. Possible explanations. Early ejection due to dynamical interactions. Undetected in current surveys. 3 exoplanets in open clusters. HD 73534b, a 2.5 Jupiter mass planet in a 177-day orbit. Implications. Challenges. Theories of planet formation in dense clusters. 4. Dark matter influence. Anomalous kinematics. Some stars move faster than expected. Hypothesis. Local dark matter subhalo may be affecting the cluster. 5. Observing M44. A complete guide. Best time to observe. Northern Hemisphere, February 8. Southern Hemisphere, low on the horizon but visible. How to locate it. Find Cancer, the crab between Gemini and Leo. Look for the two donkey stars framing M44. Under dark skies, it appears as a faint smudge. Viewing, equipment, recommendations. Instrument view. Naked eye faint, nebulous patch. Binoculars, 50 stars resolved. Small telescope, 100 stars. Some colorful, large telescope, full star field. Background galaxies. Astrophotography tips. Wide field, captures entire cluster with long exposure, reveals blue and orange stars. Narrowband filters, enhances contrast against light pollution. Conclusion. Why M44 matters. Messier 44 is more than just a star cluster. It is a cosmic time capsule, a mythological beacon, and a laboratory for stellar from ancient sky watchers to cutting-edge astrophysics. The Beehive cluster continues to inspire wonder and discovery. Would you like even more specialized details?